So let's continue, and we're going to start processing the predictions, or in our case, our only prediction. So here we're just going to define this variable, save directory, which is this one, and then we're going to add this to the end if we want to save the CSV file. We will not be running this function, therefore we will not be saving the CSV file, given that we set that flag to false, but we'll run it anyways. And this is the loop where we are going to process the predictions. You can see that that is pretty much it. Once you have the predictions coming from the forward pass and then the non-max suppression algorithm, then this for loop will save that information to disk or plot it on an image or both, depending on the flags that you have set up. So we can take a look at what we have set up here. We have save txt to true, as well as save confidence. We have high labels and high confidence to false, and everything else is pretty much by default. So let's go ahead and jump into this. Now, as usual, what we're going to do is follow a parallel path between our VS Code environment and our Colab. So let's go ahead and open our Colab now. And in particular, we're going to go all the way here to the bottom to process predictions. As usual, we're going to mount our files so we can use them. And now we're going to start to go through this for loop. Notice that pred is a list. So here I'm just saving our pred variable so we can follow this parallel path. So here, basically, we only have one prediction. So I will be 0, and then det for detection will be the value inside that first index, index 0. Scene is going to be set to 1. And then webcam, we set it up to false, so we'll step over that. And before I do this, let me do it here as well. So let's run this one. And you can see that we have our index and then our one and only detection or prediction. And then so that we can use the same information as here, notice that we have the path where we're going to save our image with the prediction overlaid on top. But we also have some other variables. So here is the image. This is the NumPy array image. And we also have some get attributes. So let's get those. And let me double click here to see where this one came from, im0s. So notice here at the top, that whole big for loop. And now we're inside another for loop inside this one. So it came from here, from the dataset, where the load images class give us a dataset with the following variables. So if I go to dataset, these are the variables that were initialized. And in particular, we're interested on the path. Not so much IM right here, but IM0S, which if you recall, if I go here, and in particular, load images, if we go there, IM0 or IM0S, which was overwritten on the output, but IM0, notice that is the raw BGR image. And then IM was the output of that image through the letterbox function. So in particular, we're interested on this one, and then, well, in our case, this will be false, and then the string. So let's go back here to detect. Notice that this is none, and then this one is, well, our string for now. So IM0S, and we're making a copy, and we're calling it IM0. And then our data set, we don't have a frame variable. So in that case, if we don't have it, then it will be 0. So let me run that. And now we have P, which is our string for the path, our IM0 image, and then frame is 0 because we're doing single image detection and not video streaming. And then P, which as we said right now is just a string, we're going to use the pathlib library, which is an object-oriented file system for paths. And we're going to use path. And what this is going to do when I run this, notice that the single string now got overwritten, and now we're using this library. Let me show you. So right now here, P, you see, POSIX path. And this is very useful because it breaks the string into different variables, different entities, that then you can call, as we're going to do, to use different parts of that string. For example, explorer.jpg clearly identifies the suffix, as well as some other information. So for example, here, save path, well, we have our save directory, runs detect.exp, and what we're going to add to that is p.name, which is explorer.jpg. So now with this library, it's much easier to concatenate and connect different strings. So you can see save path is that, and in a similar fashion, p.stem, which is just explorer. So we'll use the save directory /labels and /explorer. So let me run that. And then our text path is as we expected. So let me make sure that we're following along in our Colab environment. So in a similar fashion, we're going to import our im0s. And while we are at it, we'll also do the im.pt as well. So this for loop and this function essentially save to disk, or save in our case to our Google Drive, im.pt plus the one that we just called right here, im0s. So you can see that right now, we don't have those files there. So let me run this. And then here, I'm just printing it. And at the end, I'm just outputting all the files that are there. Sometimes it takes a moment, but you can see they're both there, this one and this one, just right now. And then we can load them with torch.load for the PyTorch and np.load for the NumPy array. Now we're in a similar point. You can see this print string. Well, in our case, we have s, and now we're going to add something to it. And what that something is, notice that im is right here, which is why we imported here as well. So what this print string is going to do is it's going to add to the existing string 640 by 640. So now you can see that s has that at the end. And now we're going to create this variable that we'll use it later to normalize the gain for the width and height, which, as you can see here as well, I'm doing the copy that we did here at the top so that we have the same nomenclature. And then im0.shape will give us this. This is our width and height of the input image, as well as width and height. We'll use this gn variable later. So let's do that here as well. And in our case, well, save crop is set to false, so it's just going to be our im0. So imc will be our im0, even though I don't think we're going to be using imc because we're not cropping the detection region in our case. This could be useful if you're going to do a two-stage detection, or you just want to save the crop region. And now we're going to create this annotator object from the annotator class. As you can see, we don't have it here because we're not going to be using it until later, right here. So I'm not going to save it in our Colab. So we'll run it here, but we'll talk about it in much more detail later when we actually need to use the annotator object. So let me run this. And now, let me make sure we're in the same spot. Now for each detection, we're going to step into this. And notice that detection has the XY, top left, and bottom right, and then the confidence, and then the class.